Hi, class. So last week we had studied the section 1.4, and we had gone down to this example here, which we had done in class. And I want to continue after that point. So here. For this one I have here 3 times x minus 2 is equal to 6 times x minus 1 minus 3x outside of that. So we are going to have to distribute the 3 and the 6 and on both the left and the right hand side here. On both of these, there and there. So 3x minus 6 is equal to 6x minus 6 minus 3x. And on the right-hand side, we can combine the 6x and the negative 3x. So that becomes 3x minus 6 is equal to 3x minus 6. Both of those sides equal, no matter what x is. So this would be one of these all real number solutions. And we would express that as negative infinity to positive infinity with these parentheses around it. This next example, I have 3/4 times 12x plus 24 minus 8 outside of that is equal to 1/5 times 30x plus 35. So I am going to distribute both fractions on both sides of this equality sign. That way, it could clear everything out nicely. And thankfully, we won't have any fractions left after that. So doing that by distributing the 3/4 and the 1/5, this is going to make 3/4 times 12 is 9x plus 3/4 times 24 is going to be 18 minus 8 is equal to 1/5 times 30x, makes 6x, plus 1/5 times 35 makes 7. So 9x plus 18 minus 8 is equal to 6x plus 7. The 18 and the negative 8 can combine on the left-hand side over here to make 9x plus 10 is equal to 6x plus 7. Go subtract over the 6x and subtract over the 10. And that's going to make 3x is equal to negative 3. And then dividing by 3 gives us a final answer of negative 1. So negative 1 as a set would be our solution to this problem. So for the types of equations, well, we were just solving a whole bunch of them. We can classify them. An identity is true for all real numbers. So like the one I have here, x plus 3 is equal to x plus 2 plus 1, since this 2 and the 1 here on the right-hand side combine to make x plus 3. So that solution is all real numbers, which again denoted by a negative infinity to a positive infinity. The one that we just did before was an example of that, which was example number 5. A conditional equation is true for at least one real number that's not an identity. So those were examples 1, 2, and 4. And an inconsistent equation is not true for any real number, such as x is equal to x plus 7, and not physically equal. So that's no solution. Empty brackets or that empty set that we saw last time. And an example of that one was example number 3. And as I put here on the bottom, why not a set containing an empty set inside of it like that? Uh, the reason for why that is because it's not empty. We have to show the emptiness, which is going to be with this empty set symbol for us to denote that in this particular case. So we can specifically attempt to categorize types of equations. I have two here. 2 times x plus 1 is equal to 2x plus 3. We could distribute the 2 on the left-hand side and be made with 2x plus 2 is equal to 2x plus 3, which, I mean, we could subtract the 2x to show it a bit better, potentially, by getting 2 is equal to 3, which is not at all accurate or true, right? So this will be, an empty set solution, right? And to categorize it, though, this is going to be an inconsistent equation. Likewise, the one here on the bottom, 4x plus 6 is equal to 6 times x plus 1 minus 2x. We could distribute that 6 on the right-hand side and be left with 4x plus 6 is equal to 6x plus 6 minus 2x. And then to combine the 6x and the 2x, negative 2x, that makes 4x plus 6 is equal to 4x plus 6. These two are equal. We could try to go further with this, but we'll still have an equality. So this one's an all real number solution, negative infinity to positive infinity, and this would be an identity as this particular solution. And then we have ourselves a word problem here, which was the one dealing with that graph at the beginning of the particular lesson. What is the cost of attending a public college? In this case, given with an equation of t is equal to 385x plus 3,129. And we want to know, when will the tuition and fees reach $10,300? So we need to solve this. 385 times x plus 3,129 is equal to 10,300. We're going to subtract the 3,129 from both sides. I'll try to make that legible. It's just tight space. Doing that is going to give us 385x is equal to 7,171. And then dividing by that 385 sadly does not make a whole number, but that's okay. X in this case is about 18.6 rounded. I'm going to round that up to a 19. So after 19 years, so in this case, since X was the number of years since 2000, this would be the year 2019, for example. So let me know if any of you have any questions or concerns. Thank you.